So on the right side of your screen, you can see all my work, and on the left side, you can see the questions. So this is a lot faster than the first one. This question, as you can see, we have the different mixes of bluegrass and rye, and the store manager wants to create a Western special with 0.6 bluegrass and 0.4 rye. So the first question is, how could they mix the pounds of deluxe, pounds of standard, and pounds of econ to create the special mix? Give a general solution. So what we want to do is that we can want to find out the equations first. So we can see that for bluegrass, what we want to do is we want to get 0.6 bluegrass, right? And that is represented by the deluxe mix, which is x1, the standard mix, which is 0.7, x2, plus the economy mix. And when we mix the bluegrasses together, we want to end up with 0.6. This is the same thing with the rye, as we want to end up with 0.4 rye. We do the exact same thing with the amount of rye in each of the mixes. And if we mix these together, we want to end up with these final ratios or amounts in the 1 pound. And remember, the last equation that we need is that the three mixes together need to add up to 1 pound, because if we were just to do one of these equations, what would happen is that we can possibly exceed 1 pound, and then our actual ratio wouldn't be 0.6 to 0.4. So we put these equations again into a matrix in order to find x1, x2, x3. And what we can figure out is that, since, as you can see, that if we add the bluegrass and the rye together, we get the 1 pound, which means that these are actually linear dependent. So we do have x3 as a free variable. So x3 is free since we really only have, since this is linear dependent, we really only have two equations for three variables, and we have to say x3 is free, since what we can see is that in later questions they are asking us for the lowest price, which means that if we want to set since x3 is the lowest priced one, which is at 4 pounds, since it is economy, we want to be able to change that, and we want to make that as small as possible. So x3 equals 3, x2 equals x2 right here, 1.5 minus 2.5 x3, and x1 is negative half plus the 1.5 x3. So these are the general solutions of x1, x2, x3 based on this free variable of x. So we can set any of them, but as you can see in my explanation, x3 is the best one to set as free. So this will help us in the next two equations, which is they pretty much give the prices of the different mixes, and they asked us to find the lowest priced special mix and what is the cost per pound. So what we have to do here is that we have to find two things. We have to first find, or it doesn't really matter which order we go in, but we have to find the equation for price based on whatever our x3 is, and we need to find the range of x3 in order to make x3 the most profitable based on our price. So price equals 4x3, because this is 4 of the economy, right? Plus $8 per pound of the standard, which is, if we put in terms of x3, is this, plus the $10 per pound of the deluxe, which is when we put it into x3, this is represented as this from our general solutions. That simplifies down to P equals negative x3 plus 7. This is the price no matter what. So no matter what we put x3 as, this will be the price depending on how much x3 we have. What we also need to do is that we need to find, obviously we can't set x3 to 0, x3 to anything we want, right? Because a lot of the times that won't fit the range of our other two mixes. If we put x3, for example, as 1, we will just end up with economy mix. We won't have our Western special as we want, so we need to find the range of, this kind of optimization, right? We need to put in the most x3 possible, since as x3 goes up, price decreases, as there's a negative relationship right here. So we need to optimize the amount of x3 while fulfilling our ranges, right? So this is the range for the first one, right? Since it's a free variable, it has to be at most 1 pound, since it has to fulfill our last equation right here. This is the second equation right here. Again, right? X2 has to be between 0 and 1 pounds, and x3 also has to be between. X1 also has to be between 0 and 1 pound, since you physically can't exceed 1 pound. So if we simplify these ranges, we can see that So we need to find So yeah, so once we solve these ranges, we can find that the maximum x3 for these two are 1, which don't make any sense since if we were to have 1, we just have economy mix. So then we have to take the next highest x3, which is 3/5. So plug in 3/5, plug it into the general solutions, and we get in order for, so the answer to question 2, it would be x3 equals 3 out of 5, x2 equals 0, and x1 equals 2 out of 5. And our final price, if we plug it into this equation right here, would be $6.40. So the next problem is extremely similar. We plug in our equation, right? And what we actually end up in this one, since now the price is, instead of 8 is 6, as if you read the question, it says $6 per pound for standard instead of 8 now, and we come up with a different equation. So P actually equals 4x3 plus 4 this time. And if we look at this equation, what we notice is that as x3 rises, P also rises. So while in our previous question we were trying to maximize x3, now we want to find the lowest possible x3 that fits our ranges. So again, we open our ranges up right here, but now we're, instead of looking at the largest one that fits our ranges, we are looking for the smallest x3. So these are our final like boundaries that fit all the equations. And as you can tell, that we actually have to use the 1/3 since 0 doesn't make any sense, and it's between 1/5 and 1/3, and 1/5 doesn't include 1/3, but 1/3 includes 1/5. That kind of makes sense. That's a little bit hard to explain, but the gist of it is that we are trying to satisfy all of these ranges, and 1/5 does not satisfy this last equation. So we have to use the 1/3. X3 equals 1/3. X2, if we plug it into the general solution in part 1, would be 2/3, and x1 equals 0. And plugging into our 4x3 plus 4, our price would equal $5.33. Thank you for listening to my explanation of question 2 take home, and bye.